Plastic pollution is breaking down into microscopic particles can enter our bodies. What if plastic could destroy plastic? This episode discusses emerging research on active bioplastics. These bioplastics become a natural remedy. They work to completely destroy plastic. Welcome to Acuitech Hub.
Let's jump right into today's explainer, because we are looking at an absolutely incredible proof of concept technology that literally flips the script on global pollution. Instead of just trying to reduce waste, the usual passive approach, what if our everyday materials actually healed the environment? Today, we're diving into a major paradigm shift. It's a concept called Eco Purge. To really grasp why this is such a game changer, we have to look at this number: 9%. Out of the roughly 500 million tons of plastic churned out globally every single year, only a paltry 9% is actually recycled. We're totally stuck in this linear system, right? We take fossil feedstocks, turn them into packaging we use for maybe 10 minutes, and then toss them. And the rest, it just piles up in landfills or leaks out into the environment, where it breaks down into these highly persistent, invisible threats.
Which brings us to part one, the microplastics crisis. Let's talk about why the sheer durability of everyday plastics is actually our biggest enemy. So when we talk about plastics like PET, the stuff used for beverage bottles and takeout containers, we have to remember they are engineered to survive almost anything. We're talking about as little as a 2% weight loss over 120 days, even sitting in a harsh wetland. But eventually, they do fragment into micro and nanoplastics. And the health impact, it's staggering. These particles aren't just floating out in the ocean. They are inside us. They've been documented in human blood, placentas, and breast milk. Actually, a recent study estimated that the microplastic load in the human brain jumped nearly 50% between 2016 and 2024. Exposure is triggering severe gut and lung inflammation, sometimes lasting weeks after exposure. And worse, they act like toxic sponges, soaking up heavy metals and delivering them straight into our biology.
Okay, moving on to part two, the passive plastic problem. The crux of the issue with how we've tried to solve this so far is right here on the screen. Conventional green bioplastics like PLA, they might degrade perfectly in an industrial composter, which is great, sure, for reducing tomorrow's waste. But they do absolutely nothing to clean up the decades of legacy PET pollution already choking our soil and oceans. A compostable cup just doesn't solve the fact that millions of tons of microplastics are already out there right now. It's essentially a half measure. So let's get to the exciting part. Section 3. Enter Eco Purge. This is an active remediation concept pioneered by a brilliant 18-year-old innovator named Arya Satish. She actually just won a $12,500 Earth Prize for this exact concept. And honestly, it represents a massive leap in material science. Looking at the comparison here, the contrast is super stark. Conventional bioplastics, they just passively die. Their beneficial life cycle essentially ends the moment you throw them away. Eco Purge, on the other hand, performs a double function. It doesn't just disappear, it actively hunts and destroys the legacy microplastics surrounding it. It's quite literally designed to clean up the environment after you throw it away. Let's look closer at part 4, the double function. To understand the biochemistry here, think of Eco Purge as a cellular Trojan horse on a highly targeted end-of-life mission. Here's how the steps play out. First, you dispose of it in a suitable environment, like soil or water. Then, the plant-based matrix rapidly biodegrades within about 2 weeks. But here is the genius part. That breakdown triggers the release of specialized embedded enzymes right into the environment. These enzymes then go to work, actively seeking out and dismantling nearby PET waste, converting it into harmless compounds. In experimental trials, both the prototype and the surrounding microplastics were completely wiped out in just 6 weeks. Crazy, right?
So how do you actually build something like this? For everyday things like sachets, films, or cups, this table lays out the proposed architecture. It relies on a PHA-rich base resin for strength, mixed with bio-based cellulose fibers to give it some stiffness. To keep it from being too brittle, they use food-safe plasticizers like citrate esters. And most importantly, for the moisture barrier, they strictly avoid any of those persistent forever chemicals. No fluorinated chemistry at all. It is a completely holistic, renewable recipe.
But let's get into part 5. The path to reality. As with any exciting new tech, we need to maintain some grounded optimism here, because the engineering hurdles standing in the way are massive. The absolute biggest roadblock: cost. To make Eco Purge work, you need a highly specialized PET degrading enzyme.
And right now, that enzyme costs $2,500 for just 3 milligrams. Think about that. That is a microscopic speck of material for the price of a used car. If you're trying to manufacture millions of tons of cheap, sustainable packaging, that price point is an absolute deal breaker. To tackle that insane cost, Satish is aiming to genetically modify E. coli bacteria to mass-produce the enzyme affordably. But there are other severe technical challenges too. Biological enzymes are super fragile. They can easily denature, basically boil and deactivate, under the intense heat required for industrial plastic manufacturing. Then there's the strict specificity. Right now, this enzyme only eats PET, so it has limited use against other types of plastic. And finally, environmental dilution. Think about releasing these enzymes in the open ocean. It's literally like putting a single drop of dish soap into an Olympic swimming pool. They might just dilute uselessly before they ever even bump into the target microplastics. Because of these massive hurdles, true commercialization is realistically at least 5 years away. However, they've already proposed a rigorous 90-day development roadmap for the next phase. This isn't just a fun lab experiment anymore. They are moving to compound things in the lab, screen the mechanical properties, conduct cradle-to-grave life cycle assessments, and eventually run pilot tests to track actual recovery rates. The goal here is a verified, scientifically backed reduction in persistent plastics, not just another empty greenwashing marketing claim.
So as we wrap up this explainer, we are left with a highly provocative vision. What if our everyday packaging didn't just passively reduce future waste, but actively healed the environmental damage of our past? If science can clear these technical hurdles, active remediation concepts like Eco Purge could fundamentally rewrite the rules of the circular economy, becoming the absolute gold standard for sustainable materials. So what do you think? Are active bioplastics the future? Thanks for joining me to explore this.
If you found this episode interesting, like, share, and subscribe.